Okay, so let's apply it. So draw Lewis structures for the following molecules. So the first one we're going to do is methane. Okay? And I will walk you through this example of how I get it. All right? And then for the other ones, I'm going to put the tunes on, and I'll work through it with some music going on, and you could pause it and work on it on your own, or work along with me. So with methane, we recognize that carbon, 1, 2, 3, 4, carbon has 4 valence electrons, and each hydrogen has 1 times 4, right? So I get 8 total electrons. 4 plus 4 to give me 8. Okay. I recognize carbon has the bigger bonding capacity than hydrogen. And at first you might think, well, hydrogen only has 1 and carbon has 4. But we have to remember hydrogen can only take 2 electrons. So hydrogen's almost never, 99.99% of the time, hydrogen is not going to be the central atom. Okay? But carbon almost all the time makes the central atom because carbon has a lot of bonding capacity. So I'm going to put carbon in the middle as a central atom. And I have 4 hydrogens and I'm going to surround it. Okay? So I'm going to say hydrogen, 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 hydrogen. I'm going to draw the bond between each one. And now I need to count up all of my electrons to make sure I use them all. So remember, I had 8 that I have to use. And check it out. 2, 4, 6, 8. So there we go. We used all 8 of them. Now we have to check that we've satisfied the octet rule. So carbon wants to have 8 electrons surrounding it, and indeed it does. 2, 4, 6, 8. Hydrogen wants to have the duet rule. So each hydrogen can only have 2 electrons in it. And so this hydrogen, right, is only, no lone pairs, which is correct. So this hydrogen is sharing 2 electrons with this carbon. So this hydrogen has 2. This hydrogen has 2. This hydrogen has 2. This hydrogen has 2. Fantastic. This is my Lewis structure for methane. So this one, you can see no lone pairs. It's very simple. No dipole moment because it's totally symmetrical. And I think I forgot to say that on the previous slide. So I'm going to make that note right here. Okay. So this SF6, it's symmetrical. And that's a good indication of no dipole moment when a molecule is symmetrical. Okay, so now let's do the other ones. I'm going to bring the tunage back on. I'm going to turn it down just a little bit. Okay, let's do it. Okay, let's work on CF4. Okay. 2, 4, 6, 8. Okay. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Great. Okay. And each fluorine is 2, 4, 6, 8. Octet rule. Carbon is 2, 4, 6, 8. Octet rule. Okay. 2. Two, 4, 6. Great. That's it. So 1 electron for hydrogen, and there's 2. 1, 2, 3, 4, 5, 6 for oxygen. Okay, 2, 4 from the bond. Plus 2, 4 equals 8. Okay, so hopefully you were able to follow along with these examples. These are all the simple examples. Okay, we could come up with a lot more simple examples. And what's also important to note, when we're doing Lewis structure, we're not necessarily concerned with getting the correct angles. We just kind of draw everything around the central atom evenly. Okay, so we'll see water is actually not shaped like this, and we'll see why that is. Okay, so hopefully all these examples made good sense, and you're able to arrive at these examples. Okay, so let's move on.